I'd like to go through this problem that we've seen earlier as a Poisson. So remember the experiment where we had alpha particles being given off by some molecule in 1 second. Okay, it told us that 192 particles are given off normally in 1 minute, so that's 192 successes per minute, or we change this around a few different times. We call this a Poisson. Okay, if we're interested in the number of successes in a given time or in a given area, then you're talking about Poisson, when you're counting the number of successes. Notice the number of successes is discrete. If you're talking about the exact same situation, however, you are talking about the amount of time, or the area, until the next success. Okay, so that's just the the inverse of Poisson. Then you get exponential distribution. Okay, so here, when I'm talking about how many successes, how many alpha particles in the next amount of time, this is Poisson. Down here, when I'm saying now if you have to wait 1 second, how many successes do you get? Okay, so when I rephrase it like the inverse, then instead of getting Poisson, I get exponential. Okay, so above here, this should be relatively familiar from the Poisson. If not, go back and review the Poisson videos and notes. Here, same situation of this alpha particle, but what's the probability we have to wait 1 second until the next alpha particle is given off? Okay, so here let y be the amount of time, and I'm going to put this in terms of seconds because here I'm asking in terms of seconds. The amount of time in seconds until the next particle. Let y be the amount of time. Time, of course, is a continuous variable, not discrete. So this is an exponential distribution. Okay, so what is the beta? Okay, it is, well, if I want it in terms of seconds, let me just remind you up here, when I found successes per second, I found that 192 successes per minute was equivalent to 3.2 successes per second. When you're talking about exponential, we want the inverse. We want seconds per success, or in this case, per particle. So what I'm going to do is I'm going to take 3 over 2, and I'm going to take the inverse of it. Okay, so in other words, I'm going to do 1 divided by 3.2, and what I end up getting is 0.3125 seconds per particle. So in this case, what's the probability you have to wait 1 second until the next alpha particle? Well, 1 second is a little bit, ambiguous. Really, you can't ever be exactly 1 second. Okay, so you can't ever have exactly 1 second. What you probably mean when you say wait 1 second is probably you mean 1 second or more, okay, or at least 1 second or at most 1 second. That's how to define this, because when you say 1 second, well, if you claim the 1 second's passed, I'll say no, it wasn't 1 second. It was 1.00000000001 second. You can't actually ever hit 1 second right on the nose. So the two different ways of answering this, you could say what's the probability of it taking less than or 1 second, or you could talk about it being more than or 1 second. And if it's the exponential distribution, we can do that either way. Okay, so we can use the formula that we've seen on the first 2 pages of the booklet to calculate this. Here, beta is 0.3125, so this is 1 minus e to the negative, y here is 1, so here I want 1 second, so that's 1 over beta, which is 0.3125. Okay, so I can calculate this in my calculator. Okay, if you want more than 1 second, equal or more than 1 second for the next alpha particle, then it's just e to the power negative y over beta. So this would be e to the negative here, y is 1, or x or y. I've got x, this should be x here. Okay, so e to the negative 1 over here beta, which is 0.31. Okay, I can show this in Minitab. When I go to calc and I go to probability distributions, I am discussing the exponential distribution. Okay, so here it's asking for the scale. This is asking for beta. Okay, so here I can put in 0.3125. The cumulative probability will be less than or equal to, okay, so I can calculate this by then saying if I want to find out less than or equal to 1 second, I've got the cumulative. We're not ever going to use this option in this course, okay, so you don't ever have to click on the probability density. We're going to use the cumulative probability. We may use the inverse cumulative probability. Here's where beta goes. Don't worry about the threshold here. Always leave it as just 0. And when I press equal, then here I get about 95, well, I guess about 96% chance that I'll have to wait less than 1 second before an alpha particle is given off. And if I wanted wait more than 1 second, of course, I can just do 1 minus this answer to give me this answer.